Thousands of wind turbines are rising from the sea. One of the most ambitious construction projects in the world. And Britain, an island nation, is the pioneer.
It's new, everything is new. It's stepping forward, stepping into the new generation.
But working out at sea is far tougher than on land, and the costs are much higher.
It's inherently complicated, it's in a difficult environment, and it's unsurprising that it is really almost staggeringly expensive.
So, in the drive for carbon-free electricity, does it make sense to turn to the ocean for this new kind of powerhouse? The story begins on dry land, at the dockyards where they built the Titanic. These are components for a new wind farm. They're enormous, and before they're installed out at sea, this is our best chance to get a sense of their scale. This is the very tip of one of the largest wind turbines in the world. I'm at the Harland & Wolff shipyard in Belfast, and this is the assembly area for a new wind farm being constructed out in the Irish Sea. Now, it can be difficult to get your head around the scale of this project, but this one blade weighs 22 tons, and it runs for an extraordinary 61.5 meters. It takes quite a while just to walk to the other end. To put this in perspective, this is slightly longer than the entire wingspan of a Boeing 747 jumbo jet. The whole thing is made of fiberglass. Sounds pretty robust, and as you can tell, the nearer to this end that we get, the thicker and more robust the whole structure becomes. You can imagine the kind of stresses and strains this will experience, buffeted by the winds out in the ocean. At last, we've made it to the very end. So how on earth do they fit this onto the hub? Well, you can see this one over here. It's got 3 blades fitted already. It's about to be loaded onto a ship. Let me show you actually how they do the fitting. The key is these. 128 of these massive bolts fitted in a ring to hold the blade on inside here. When each blade is fitted, a delicate maneuver follows. Moving them takes real care. Everything is controlled from a tiny cab with a bird's eye view. It's hard to make out at first, but the little red bubble is where the driver sits. Robert Childs has one of the strangest jobs around. Inside the crane, a staircase leads him to the controls. He ends up suspended high above the ground. I join him inside. It's cramped. The next stage of the work is about to begin. How high are we right now, roughly?
100 metres, 300 feet.
And we're right above these extraordinarily slender wind turbine blades that you're lifting them around. How difficult is that?
They do pose a challenge in that they're obviously a bit lighter and very susceptible to the wind catching them.
Ironically.
As they're designed to do. So we do rely a lot on the ground crew who will have tag ropes on and keep them as steady as possible.
How tense is that for you compared to carrying a great lump of steel?
It is nerve-wracking. There's a lot of pressure. They're not something that you want to be bouncing about off different structures or even off the crane, as you know, they can get quite close to the legs of the crane.
Inch by inch, the rotors are lifted off the ground. Their immense size takes getting used to. This is cutting-edge technology, but it still needs brute strength. Teams of people to steady the blade. Ironically, wind is the last thing they need right now. Then, very slowly, the giant crane crawls along the tracks, carrying its precious cargo. This is the process speeded up, the rotors being ferried to the barge. Each wind farm is built slightly differently, new technologies and new techniques being tried out all the time.
It is a new industry and we learn by everything we do. I mean, that's the key, that anybody coming onto the project has the ability to say, hang on, I've seen a better way, or have you tried this way? We're open to suggestions by people working on the project, people visiting the project, people even at home watching this may come up and say, why do they do it that way?
The final stage of loading. Britain has more offshore wind installations than any other country, but the turbines here are German, the Seajack barge is Danish, and the power company behind the project, Vattenfall, is Swedish. But how reliable is this technology? Some of the first wind turbines out at sea broke down sooner than expected.
They are projected to have lifetimes of around 20 years. Now, we have seen some cases that they had to be pulled in after 8 years. And it will be interesting to see if there are single events or if this is a pattern. If it's a pattern that in the North Sea we actually have to exchange and change out equipment after 8 years, that would seriously dampen the expansion of offshore winds.
The barge is towed very cautiously offshore. Our journey out to sea is much faster. We travel by high-speed catamaran off the coast of Cumbria. The crew know the route well. It takes us past wind farms already built. Out at the site, one of the biggest challenges, fixing foundations. One wind farm started subsiding. At this one, they hammer the legs 40 meters deep into the ocean floor. It's all more difficult than on land.
There are still a lot of unknowns, I think, and we're still in the early stages of the industry, so the foundations are still relatively expensive and will most likely come down in cost in the coming years. But then you have also all the operations, so such as you have to use these vessels to get to the turbines, you have to have a very expensive installation vessel to lift the turbines offshore. And all these kind of costs are not included in the onshore wind farms, so it really starts to build up the whole cost of the project.
Boats race back and forth, carrying construction workers and maintenance people. This is becoming an industry. But some experts say that offshore wind just isn't affordable.
Offshore wind is a very, very expensive way, a very difficult way of reducing carbon emissions. And there are better ways, there are cheaper ways, and quite frankly, climate change isn't something that we can have nice little experiments on building, enormous projects offshore. Climate change is something urgent which requires us to do stuff quickly. And to choose one of the most expensive ways of reducing those emissions, rather than using cheaper and more direct routes, is a luxury that, quite frankly, the consumers can't afford, and basically the planet can't afford either.
This wind farm cost about £500 million. Quite a price tag. But the industry says it's worth it, and that future projects will be cheaper.
We're confident that costs will fall significantly over the next 10 or 20 years as we understand how we do things much better.
Because people are worried about the rise in their power bills, and then on top of that, the extra costs of going green.
Yes, I think you have to understand what the alternatives to not investing in renewables and low carbon generation is, and that is of course a world in which we're not being able to tackle climate change and all that means.
As we draw near, the Sea Jack is still down at sea level, ready for us to climb aboard. Now, one of the trickiest things about working at sea is getting from one vessel, like this one, to another. So here we're lucky, we can just use this ladder. There's not much swell. Am I good to go?
Yep.
Hi there.
Hello.
As soon as we're on, the Sea Jack rises. Bundles of cable start to move. They're winching 4 legs down towards the seabed. The weight involved is incredible, the strain massive. But the Sea Jack, as you can see in this time-lapse footage, rises from the water, standing on its legs, with us on it. So what happens now? Well, the tower is about to be assembled. This is the lower section. Waiting for it, a team of technicians, dwarfed inside the structure. The tower needs to be lined up exactly. The giant tube is rotated very gingerly. Eventually, a particular pin is guided by hand into the right place, and the section can be lowered into its final position. The operation is masterminded from the bridge. In the high-tech control room, the captain keeps watch.
This is very challenging, and especially on this project because the turbines are so big. It's a pretty difficult lift to do here, and heavy also.
And it is a very calm, beautiful, sunny day.
Yes, it is. It's a nice day.
What's it like when it gets pretty wild weather out here?
Well, of course, we have a criteria within we can operate as per wave height, current, wind, and so on. So it depends on the day and what the weather forecast is also.
Have you been through some pretty big storms?
We try to get out before the storm comes.
The day wears on. The tower is ready, but there's still a lot to do. The next essential component is raised into place. It's the nacelle. Each component has to be carefully lifted into place, so now it's the turn of what they call the nacelle, the giant box that contains the gearbox, the generator, and the control systems that'll sit up at the very top of the turbine. Delicate operation, getting it up past these giant blades yet to be installed. All being done by the crane driver in that little blue cabin there, and he's in command of a pretty extraordinary machine in its own right, this crane. If you look down below, you can see this great turntable. The whole crane can pivot in any direction right in the middle of the ship. Gives it extraordinary flexibility. Let's see where the nacelle's got to now. A little bit higher, inch by inch, and look where it's got to get to. Right past the crane, up to the very top of the tower, and there's one of the specialists waiting to greet it. An extraordinary operation, not over yet. It's high summer, and at about 9 o'clock, dusk has fallen. The construction site is bathed in floodlight. The final stage of the work is just getting underway. It's late evening, but the work just keeps going as they enter a critical phase, lifting the giant set of blades off the deck. They're now angling this huge rotor so that it's in the right position to be hoisted right up and fitted to the very top of the tower.
Right now we're over roof.
In the dark, up at the summit, a face appears. A giant shadow is approaching.
Slowly start tuning the rotor back again.
The voices over the radio remain calm. The wind picks up slightly. This is now the greatest danger. Down on deck, a team clutches the tip of a blade. It has to be kept from hitting anything. It's the moment of maximum tension.
You slew to the right, Peter. Just a touch to your right. Really slow.
But gradually the hub gets closer and closer to its destination. And then it's fixed. Just before midnight, job done.
Down and hold you high again, Peter, please. Boom down and hold you high.
Soon after dawn, the sea jack has been lowered and it's time for us to leave. The barge is heading back to Belfast for another load of components. There's one more leg of our journey to come. The wind farm is almost complete. Workboats cluster around the towers. The turbines are being connected to the grid. Each one should generate 5 megawatts of electricity, a lot more than most, but still, you'd need 200 of them to match the output of a conventional power station. Getting onto one isn't easy. It involves the same elaborate procedure we went through to board the Sea Jack. The launch is being pushed again. Step forward. Yep. 1, 2, 3, 4, 5. Reach for a hook. This is the moment our ascent begins, and this is where we've got to try and get to. Right up to the top there, up to those blades. Apparently, we can get up onto the roof and have a look out, and this is the way we'll do it. Through this huge door, the base of the tower, a bit like entering a submarine or a ship. Okay, here goes with one of the longest ladders in history, I'm sure. There is a lift. I could have used it, but we thought for the authentic wind turbine experience, and also to show you how ridiculously big these things are, it would be better if I went through the ordeal of the long haul to the top. Inside, it's a very long journey to the top. I'm hooked on for safety, but the technicians who work in here have to be specially trained, and they need a head for heights. Up top, we've now reached the key mechanisms, just behind the blades. The nacelle, which holds the gearbox and generator. There's one more stage to go. So this is the final stage of the journey, right to the top. First impression, it's an incredible view. Sun's come out, sea's glistening. Look at the size of that one blade stretching right up against the blue sky. Now all of these are immobile at the moment because they're not yet commissioned, but they soon will be, benefiting from the great breeze, beautiful breeze, up here out at sea. This wind farm should generate the power needed for 100,000 homes, but only when the wind spins all of its 30 turbines. Britain, surrounded by ocean, is committed to getting a quarter of its electricity from offshore wind by 2020. Germany, Denmark and Holland also have serious plans for wind farms at sea. But will this catch on globally? Well, maybe not.
You can never exclude that in some parts in Asia we do find good conditions and some country starts to experiment with offshore wind. But we should also not forget weather patterns, storms, typhoons, these sort of things. So I would say there are no indications at the moment that we will see a large global spread of offshore wind.
So, does it really make sense in Europe? Each extraordinary construction has to be supported by generous subsidies, paid for by consumers. So how's that justified? Well, one aim is to get electricity without producing greenhouse gases. Another is to become less dependent on fuel from abroad.
One of the great benefits is that it's homegrown electricity. And in a world where we have to rely on perhaps foreign suppliers of oil and gas, which can get increasingly expensive over that period, it must make sense to be able to use our homegrown electricity.
So, a graceful vision of green power in a carbon-free world, or a gamble with uncertain technology just when the economy can least afford it. There are plans for new wind farms on a far larger scale than anything built now. The next few years will decide if they ever happen.